Hello everybody and welcome to a continuation on yesterday's Factorio tutorial. So yesterday we were looking at loading up a chest and unloading it, and then loading it up again once it was full. This is using that as a base, so if you haven't seen that, there'll be an annotation on the screen that you can click on, or just check the description, it'll be down there as well. I suggest you look at that first because I won't be going over how that half of this system works. So today it's been extended to now load up the chest. It'll wait a little bit, then once a tank enters this loading unloading zone, it will empty out all the contents from the tank. It will then load everything from this chest into the tank, and then the tank can go on, and then it will refill this chest with what we've configured the chest to have. So just a quick demonstration how this all works, and then we'll go on to how this setup works. So there we are, we're unloading the contents of the tank. Now we're loading up our new contents. One thing to remember is you can't actually unload the tank's fuel or its, munition slots. You can only unload from its trunk. So we just have this set up so that it will load into these two slots, and then the excess just goes into our trunk. And there you go, as you can see, once you're done, it'll move you off the loading unloading zone most of the time. Okay, so getting out of that, how does this work? So if you remember yesterday's tutorial, we had two stages. We had loading a chest and unloading the chest. Well, we've added to that 3 new stages, and if you remember our falling edge detection system, which are these two combinators here and these two here, you can actually see that we've got the 3 new stages, or just extend this falling edge detection system. So this stage here controls our weight, this stage here controls when detecting the tank rolling up, and this stage here controls figuring out when the tank has no more items in its trunk. So one other thing that has changed is that the unloading stage is now, well, it's the loading the tank up stage, I guess, is now at the end. So the stages are 0 is loading up the chest, 1 is waiting, 2 is detecting a tank, 3 is waiting for the tank's trunk to be empty, and 4 is loading the tank. Otherwise, this system is pretty much the same as it was yesterday. We have actually added read hand contents on hold to this inserter, and this inserter is now a long-handed inserter, and its output goes to the same decider combinator that reads from the chest. So before, this used to have a falling edge when our chest was empty. Now our chest and our inserter both need to be empty for it to have its falling edge. The reason this is a long-handed inserter is I like this sort of stopping pad, and if you have an inserter trying to insert onto a stopped conveyor belt like these all are, it actually doesn't detect when you drive a tank to it. That's why this one square here doesn't actually have a conveyor belt on it. That's essentially our collision box for the tank, for these two inserters to add items to it and take items from it. So that's why this is now a long-handed inserter, just so that it can do that. So continuing on, I will now talk about essentially the 3 new stages and how they work. So firstly, we'll look at this timer stage. So the red line, the red wire that goes on to these electric poles, it contains what stage we're at. In fact, I'll turn these on again for the moment. So that's on red 101 now. I've rewired it so the number changed. So it goes to this decider combinator. And now we have a decider, an arithmetic, and a decider combinator. And these 3 actually serve a purpose that we've kind of seen before. These are a rising edge detection system. So while these ones detect when we're going from something on to something off, these will detect when we're going from something off to something on. In fact, if you notice, all my edge detection systems actually have a light hooked into them. So you can see this one's currently on, this one's off, this one's off, this one's off, this one's off, and this one also has a light connected to it the same way, so it's off. So on what scenario is this edge raised? Well, it is raised when signal 0, so when our state is the waiting state, state 1. So on the tick that we start waiting, this is a rising edge detection, so 0 is 1, output of 1, 1 plus 0, output 2, exactly the same way our falling edge detection system works. There's some sort of state or 1 tick delay, and they both go into this decider combinator, which is flipped to the odd one. So while normally we would say, oop, I just started it waiting, that's annoying. There we go, that'll get rid of that. I'll have to check which state it's in, because it's probably in a really weird state now. Well, normally we are, if our old state is greater than our new one, so we used to be high, now we're low. But now we check if we used to be low, but now we're high. I'll just set that back to a plus, and we're in stage 3. That should be fine. Actually, that's interesting. That means that stage 2 probably isn't required. I hadn't thought of that. Yeah. Anyway, continuing on. This says, on our rising edge, we will output B's input count. Just give me a sec, I'm gonna check if that works. So I'm back, and you may notice that I've changed things slightly. So we no longer have the second step of the system. So now what we do instead is we will load this chest with contents, depending on this combinator. We will then wait a bit of time. We will then unload everything from the tank, and then we will load the tank with everything on this chest, and then it will restart that. So I discussed how the timing circuit worked. No, I didn't. I was starting to discuss it. So let's continue. So we have a rising edge system here. And so this will send out a signal 0 of 1 on our rising edge. Now that goes into this decider combinator, which says on our rising edge, output what our input count is for B. Now B comes from this constant combinator, and it's the value that I use for my timing circuits. So because there's 60 updates per second and B is 300, it's a 5-second timer. And so this will output 5 seconds. That goes into this arithmetic combinator, which is set up as a memory cell again, so its output is connected to its input. Output to input should signify the correct direction. And it's also set on its grade 9 to get this input. So it will get set to 5 seconds. Then this combinator says every time we've got more than 1 tick to wait, output C of 1. And this one changes C to a negative number and outputs it as B. So this is a negative feedback loop. And so if we're greater than 0, well, greater than 1, take 1 off. Now the reason why this is greater than 1 is you have to remember this is a 1 tick delay. So when we're set to 2, this will be telling it, okay, we're set to 2, so take off 1. But on the previous tick, it was set to 3, and so it's already getting told to take off 1. So this thing's already saying, okay, take off 1 on the next tick. So on the next tick, this will be at 1, because this will have told it to take 1 off. This will be outputting, okay, we need to take another 1 off. And so on the final tick, this will output, okay, take another 1 off, so we're at 0. This is not telling it to take any more off. And that's essentially how that system works. I don't think that was the best explanation, but you can play around with this layout and you'll see that because this delays by 1 tick, we actually want to stop telling it to take values off when we're 1 or less. And that just leads into this falling edge detection, just anything greater than 0. You know, you could say B is greater than 0. I mean, this is memory cell, so we're just each thing outputting it again. You know, you could say B plus 0 output to B and that, but you know, it's just easy to have these as generic as you can. And so that's our falling edge detection system here. Onto the second stage now. Yeah, good, that's set up correctly. So, the second stage firstly goes into this combinator, which says on the taking items out of the trunk of the tank stage, which is stage 2, output signal 1 value of 1. And that's a requirement for this stack inserter to work. Again, you know, you could just hook it straight up to the red line if you wanted to. Before I used to have it on stage 2 and 3, but you know, I've gotten rid of the old stage 2 now, so now it only works on one stage. And this is set to read hand contents in hold mode. So this is telling it you can now pull items out. Obviously there's nothing for it to pull out, so it doesn't matter. But when there is a tank there, it will start pulling items out, and it will tell us what it's pulling out. So, where does this green line lead us? It leads us over to this combinator. It is set for if there's anything greater than 0, output a value of 1 for A. So if it's grabbing anything, because we don't know what it's grabbing, you know, it's just emptying the trunk of the tank. So if you're emptying anything, output A is 1. That goes into this, which says if A is greater than 0, output B of 1, and B here is set to 20. And we've got the same circuit here of a countdown timer. So it's exactly the same setup for these three as they were for these three. So for every tick that we're holding an item in this inserter, we want to add 20 ticks, which is 1/3 of a second, to this countdown timer. Now, the issue with that is you don't want this countdown timer to go, you know, out of control and go to some massive range like, you know, maybe 4,000, 5,000, 6,000 ticks. You know, 6,000 ticks, that's 100 seconds. And you don't want to have to be waiting 100 seconds just because your trunk was full, that it was, you know, unloading it for so long. So the slight difference with this timing circuit is we have this second line. Now this second line makes sure that we're kept within a bounds. So this says if we're going to be waiting for more than 2 seconds, output C is 1. So it's essentially the same as this. But this time we're doing C times -30 instead of C times -1. So now the values for this, -30, this 120, and this 20, they're all kind of, they need to be in tune. So this value sets what your upper limit is. So we're never going to be waiting more than 2 seconds. So no matter how long this inserter is running for, the maximum value this can get to is 2 seconds. Now this -30, it needs to be firstly greater than whatever our input is. If it's less than, you're not capped anymore. If this was -10, then that just means that every time we're above 2 seconds, we're only adding, you know, 1/6 of a second on, instead of we're taking time off to make sure we stay in those bounds. But the other thing you have to be careful of is your lower limit. So we'll assume that this inserter has put down its last item, and when it does that, this counter is at 121. Exactly, and we'll also assume these two don't exist, just for the moment, because they're only changing it by 1, so they're mostly negligible. Irrelevant. We'll go with irrelevant. Continuing on. So we're at 121. That's greater than 120, so this says we need to have C's 1. But nothing happens that tick because it takes a tick for it to send it through to here. The next tick, it's still greater than 120 because it's still at 121. so it sends it through again. On this tick, this thing gets a C value, so it tells it to take it down by 30. So it says, okay, next tick, this is only going to be 91. The next tick happens, it's at 91. This thing is no longer telling it to take any more off, but the last tick it still told it to take something off, so it still has a signal C. So we take off another 30, and so now we're down to 61. And so what that means is essentially the value you get from here, this sets what your maximum wait time can be. And your maximum wait time minus 2 of whatever this is your minimum wait time. So there's no way this thing's going to get below 60. Because, you know, double 30 is 60, 120 minus 60 is 60. So it's going to wait at least 1 second and at most 2 seconds. That's just how you tune this so that you can set how long it's going to wait for. This again goes into exactly the same circuit we have here. We basically just made 2 new timing circuits. And these are exactly the same. And they're all just connected to that. So yeah, we have a timing circuit which is triggered once when we get into the waiting stage, and we get a timing circuit that is renewed whenever we have items in this inserter. Apart from that, everything else is essentially the same. We do have, obviously, you know, these belts. They're set so that if our stage is less than 2. So if we're filling up this chest, or if we're waiting at stage 0 and 1, then these are enabled. So when we're filling up or we're waiting, you know, these are turned on, and I'd say about 3/4 of the time. However, the tank decides to move when it's on belts, it gets triggered and it will move on. About 1/4 of the time, it must, you know, assume it's on this part of the world, and so the tank doesn't actually move, and you need to tap, you know, forward to make it move. Apart from that, I added some extra lights. So we just have, you know, on our stages where these are turned on, send out a green signal, and on the stages where they are turned off, send out a red signal. So these are essentially just the same as these belts. So the lights are red when you're meant to stop, and they're green when you're allowed to go. These lights down here on our emptying items from the trunk stage, they're green. On the stage where we're waiting a few seconds, they're yellow, and on all other stages they're red. And so this is why it's a little odd to allow that. So the red wire, which has either green or yellow, goes to both our lamps. It also goes to the input of this decider combinator, and it is on the green wire that it sends out its red signal. Because otherwise, because it's just set to everything, if everything's 0, send out a red. If it was hooked to itself, it would just flash on and off every tick, because it'd be like, there's nothing that's on, so I'm going to send out red. And then it's like, oh look, red's on, so I'm not going to send out red. And so that would be annoying. So that's how I got around that. Apart from that, this is just to align the tank so that it's in the correct spot. Yeah, if the tank's too far over this way, it'll move across, and if it's too far over this way, it'll move across. And we want it so the right half of the tank is on this line. So that's what this first part is for. So this first part will essentially make sure either the left or the right is on the left lane, and then the second half makes sure that the right half is on the right lane. Yeah, and so that's how that whole system works. Again, if you have any questions, you know, feel free to ask. Otherwise, have a good day, and yeah.